Hello, I am Snehil Verma, a third year undergrad student presently pursuing production engineering at BIT Mesra, Ranchi. The project I am working on is titled as Formulation of Welding Flux Using Mill Scales. About the project. First of all, what is mill scale? Mill scale is the flaky surface of hot rolled steel consisting of majorly oxides of iron. The project aims to investigate the possibility of producing mill-scale based arc welding electrode flux by using mill scale from local industries. Since mill scale is considered as industrial waste, hence this project can also be referred as management of waste. That perhaps has become an important issue due to ever-tightening environment regulations. This project is under progress and significant process findings till now have been presented here. Objective. The main objective of doing this study is to explore the possibility and feasibility of using mill scale in formulating flux of arc welding electrodes. Shown below is a flowchart which gives you a visual representation of the objective. Why this project? Here are the three highlights that made me realize the significance and need of this project. First of all, mill scale is currently treated as industrial waste and sold at a very nominal price. So if it can be utilized in welding flux coating, it will play a significant role in lowering the cost of electrodes. Second, it is available to us in huge amounts which can conveniently help us cater the exponentially increasing welding consumable market. And the third is, mill scale usually contains 80 to 95% oxides of iron, and this property makes it a very useful resource. Let's first briefly go through the process of formulating flux and manufacturing electrodes. Initially, the different ingredients of flux are weighed according to their proportions and mixed, as can be seen in the first image. The mixture is then put into the blender where binders and extrusion agents are added to it to form a homogeneous flux. This can be viewed in the second and third images. Once the blending part is done, the mixture, so-called flux, is fed to the extrusion machine where it is coated around a wire rod of predefined dimensions. This results in forming of electrode as shown in the first image. After extrusion, the electrodes are air-dried for 36 to 48 hours and then baked in oven for an hour or two. Then finally, the testing is done to assess the physical and chemical properties of electrodes. Journey so far. Here, a phase-wise representation of flow of work is stated. The ingredient list shown under phase 1 was the initial composition proposed to formulate the flux. The trial conducted for phase 1 failed as the mixture, or rather flux, after blending turned into a very hard coagulating substance, making it impossible to extrude. So, to counter this issue, Cepol was added to the composition. The function of Cepol is to loosen the mixture and serve the purpose of an extrusion agent. Now, the new ingredient list was the composition for phase 2. The trial conducted for phase 2 succeeded, but extruded electrodes had poor grip of flux, rough surface finish, and difficulty in slag removal. Now to remove these defects, alpha cellulose and rutile were added. Where rutile eased the slag removal, alpha cellulose took care of surface finish and grip. Currently, I am working on phase 3 module with a composition as shown in this slide. This module has been divided into 3 samples by varying the proportion of rutile. These 3 samples were tested and a visual test result has been shown here for both AC and DC currents. The results are quite promising, though we still face few challenges. The challenges are: bead formation pattern needs to be improved further as the welded area shows slight discontinuity on the surface, due to which the mill scale flux weld does not get the same surface finish as that of the procured one. These trials have answered the question of possibility, and I am working upon how this possibility can be converted into an opportunity to revolutionize the welding consumable sector. Conclusion. Once the possibility and feasibility of mill-scale flux is validated, it will be a pioneering effort towards the welding electrode market, as it would significantly decrease the cost of electrode and will be one of its kind. The mill-scale flux would cost 50 to 60% less as compared to usual flux in the market. Its validation would not only grant monetary benefits but also would be a promising step towards recycling and waste reduction, hence making a positive impact on our environment. Thank you.